Hi guys, today we'll be looking at a question on quadratic number patterns. So the following information is given about a quadratic number pattern. T1 is equal to 3, so we would have 3. T2 minus T1 is equal to 9, so we know our first difference is 9. So if we say 3 plus 9, we get 12. T3 minus T2 is equal to 21, so our second difference is 21. So if we add 21 to 12, we get 33. And here we can see our second difference is 12. For question 2.2.1, they say show that T5 is equal to 111. So since it's only 2 marks and you already have the third term, you can just keep going. Or alternatively, you could do the 2a is equal to 12. In this case 12, and then 3a plus b. But I think they are going to make us do that in the second question, so we can just keep going with this. So we know the constant second difference is still 12, so 12 plus 21, that gives us 33, and then 33 plus 12 gives us 45. And here 33 plus 33 is obviously 66, and then we get 111. Therefore, we can show that term 5, being 1, 2, 3, 4, 5, is equal to 111. Question 2.2.2. Show that the general term of the quadratic pattern is Tn is equal to 6n squared minus 9n plus 6. So here we would need to do our 2a plus b, a plus b plus c. So 2a would be equal to our first difference, which is 12. Therefore, our a value is equal to 6. 3a plus b is equal to our first difference, which is 9. And if we know a is 6, we can then calculate b to be equal to negative 9. And then a plus b plus c is equal to our first term, which is 3. And we have a being 6 plus negative 9 plus c is equal to 3. Therefore, c is equal to 6. So our term is Tn is equal to an squared, so 6n squared, plus bn, but b is negative 9, so minus 9n, and then plus 6, which is c. Question 2.2.3. Show that the pattern is increasing for all values that n is equal to the natural number system. So you could show this two ways. You could firstly get the derivative of your Tn and set it greater than 0. And whatever your n value is, if it's positive, then you will only have increasing numbers. Or alternatively, you could look for since it is a positive parabola, we have a positive n squared, you could look for the minimum value. Either way would be fine. I'm just going to do it the derivative way. So Tn would be equal to 6n squared, which would become 12n, and then negative 9n would become negative 9, and 6 would just fall away. And we want to set it greater than 0. And if we solve for this, we get n to be greater than 3 over 4. And 3 over 4 is the minimum value that this pattern will have. So therefore, Tn. And that's all for this question. Thank you.